So the one you're going to see the most often is the panel, and that form factor is really popular just because it's very industrial. A lot of panels have a metal backplating, or they're kind of tougher plastics, and there's a lot more screws and robustness that can go into a panel design just because it's a PCB inside. So it's not like a Yagi that has metal elements that need to radiate and need free space. The panel can have a little bit more robust and tough housing, which is great for highways and industrial settings, construction sites, things that need to just stay there for a long time, take a lot of beating from the weather and the heat and cold and all that sort of stuff. Then the next one you're going to see a lot of is sectorial panels, and these are the ones that look the most like cell tower antennas. And just by looking at them, you really can't tell if it's a cell panel or a Wi-Fi panel. And basically, if you were to open up one of those sectorials, you would see a bunch of little panels all lined up and tilted left and right. So it's not one big antenna, it's actually a series of antennas that all join in together. And these come all in different flavors depending on your gain and how much spread you need. So sectorials are typically in 120 or 90 degrees from left to right, so they're very far reaching left and right, but also have high gain ratings, which means that they will reach further. And one single antenna can't do that. It's actually an array in a combination of antennas that do that. So the next big one that you see a lot for rural areas or point-to-point camera settings on the highway and that sort of thing is a parabolic grid. And that's just a big dish with a stick coming out in front of it, and that is just beaming a laser pen of whatever frequency it's supposed to be on. And the same thing, you can't tell right away whether or not that's a Wi-Fi or a cellular band or a 5 gigahertz and that sort of thing. But those are the basic form factors for most antennas that you see on long-range applications. Smaller antennas are hidden inside devices like IoT stuff, and those are the kind of ones where they're a little bit harder, but also harder to see and know that they're there. But those are the ones that are hardest to increase the range on, because if your device doesn't have a detachable antenna port, whether that be with an SMA or an N-mail type of connector, you're not going to be able to put any bigger antennas unless you open it up and solder something onto that antenna board. Our omnidirectional antennas are also really popular just because they're really strong. We make everything in the US and we back it, and we have really great results with our omnis. They have a really flat signal, which is great for reaching out further out, but then we have lower gain omnis that are fantastic for home settings. So if you have a larger home and you want to get signal toward your backyard, or maybe to a second guest house, for example, that's a common one we get. Omnis are great for sending signal all the way around, because then you get in the back and maybe you have a gate that needs Wi-Fi or a camera somewhere else in the property. So Omnis work really well for that. So our big focus right now is, of course, getting into pen testing AC, 802.11ac, 5 gigahertz stuff. So everyone knows the very large dish 2.4 gigahertz 24 dBi parabolic that's been on the market for a long time. We redesigned the feed horn to allow for dual band capabilities, optimized at 24 dBi and 27 dBi, which basically means very far reaching, narrow beam with point-to-point transmissions. Everyone who has a 24 dBi parabolics is going to be able to buy just a feed horn, keep the same dish up there, make a swap, and now you just upgraded and future-proofed for the time being your very far-reaching antennas. And at the same time, anyone who looks to kind of play into new frequencies and new bands, the possibilities right now are endless in terms of long-range capabilities.